today we're going to start, we're going to kind of leave off where we left off last week. I just want to give a potential solution to the homework that we offered up last time. And then we're going to actually get started with a game. So today's session is on logic, variables, and operators. And essentially what we're going to do is we're going to make a game where Scratch the Cat is going to be catching things that are falling out of the sky. Some things are good, other things are bad. He's got to avoid the bad things while catching the good things. And this first project that we did right now is kind of just a good jumping off point because we've got some of the basics of how each Scratch program works. So just to recap what we went over last week, we had Scratch the Cat here. I've got him highlighted in the sprite window, and he's on the stage here. When we start our program, he moves over to where the cowbell is, or sorry, he moves to his start point, points to the right, and then moves over the course of 3 seconds over to where the cowbell is. And then the cowbell, when we start our program, it's doing a loop called forever that checks if Scratch the Cat is touching it. If he's touching it, then it plays the cowbell sound. And then I've added this little block. This was kind of my basic solution to the homework problem, which stops the program from running. Moves over the course of 3 seconds. Bob, I'm going to have to mute you again because I'm getting a delay from your audio for some reason. So the block that I added here is the stop all block. And what that does is, it's just like it sounds, it stops all the scripts happening on our game. So if I hit the flag, Scratch the Cat will walk over, the cowbell will ring once, and then the app stops. You'll notice that the stop button kind of blinked when we did that. And then this is no longer highlighted in yellow, and this is no longer highlighted in yellow. So let me just restart our program here. So you'll notice it's highlighted in yellow, highlighted in yellow. That means it's running, and then once it stops, it turns off the highlight. So our program essentially stops. It's the same thing as if we had hit that stop button. Now there are some other options here. There's stop just this script, which would keep the program running, but it would just stop this little block of code from beginning to end. And then other scripts in this sprite. So if we had other scripts running at the same time, checking for other things, and we'll get there with our full game, but that would stop those other scripts and keep this one running. So that's kind of the solution to the homework. What I'm going to do now is I'm going to start a brand new project in the Scratch editor, and this is going to be kind of the start of our game that we're actually going to create. So right off the bat, I'm going to kind of do some similar things to what I did with the first project, which I'm going to click on my stage here in the bottom, and then I'm going to choose the option to pick a backdrop from the library. So this just kind of sets what the level looks like. I typically like to pick stuff that has a definite ground and sky, or a definite area. That way we can position our character on there. So let's just find something. We'll do space this time. So right now that puts Scratch the Cat in space. He's kind of just floating in the air right now. We're going to fix that. And you'll notice that it's automatically switched to the backdrops tab. So if we wanted to, we could use these paint tools and kind of add on to our background. I'm not going to worry about adding anything on. So I'm just going to switch back to our scripts tab. Now, as I mentioned last week, the stage itself also has a script block. So it's really important that when we actually start adding our code blocks to this, that we're on the right item. We don't want to be on the stage. We want to be on our character, because our character is going to be the first thing that we want to get moving, that we kind of actually want to make interactive. So want to make sure that we highlight Scratch. I'm going to click the little letter I and just set those same options that we set last time. So scratch the cat for his name, and then I'm going to change that rotation style just so he only flips left and right. Again, depending on what type of game you're doing, you may not need to change this rotation style. If you are doing something like a racing game where you're looking at a car from the top down, then obviously you'd want to be able to rotate your car all the way around. But in this case, because we're kind of in a side view of the game, I just want him to flip left and right. So now I'm going to move Scratch kind of closer to the bottom of the screen, just so he's got a little more room. What's going to be happening is we're going to have items that drop from the top of the screen down to the bottom. And once they get past this kind of floor that we've hit, so essentially below where Scratch is right now, Scratch the cat, I mean, we'll deduct a life or a point or something like that. There will be some kind of logic that we go through. So now we've got Scratch at the bottom, and we need to start our script the same way that we started the other ones, which is with this when green flag clicked. So all we're saying is when our program starts, we're going to do these things. And so here's where we're going to get into our first bit of logic. So I'm going to do this in two different ways, just so that, again, I don't want to teach you just one way to think about things, because with everything, there's more than one way to do something. And as you kind of work through your program, you'll see what some of the different ways are. So I just want to introduce you to a couple different ways to do this. The first one is not the one I recommend, but it's an easy way to kind of show the interactivity and the logic of a program. The second way is probably the way that we'll end up continuing on with. So our first way that we're going to do this is we need to get Scratch the cat to interact somehow with the keyboard. We need to be able to move him around. And you'll notice that when I'm on the events block, I have a couple other events, and really an event is just when something happens. So when something is clicked, in this case the green flag, when the space key is pressed, when a sprite, one of our characters or our items, is clicked, when the backdrop switches, things like that. So our most basic event that we can do is when we click on a key, something happens. So in this case, I'm going to move this block here, and we'll get back to our question mark block. But when I press something like the left arrow, for example, I can tell my script to point Scratch in the opposite direction and then move a certain distance. So now when I start my program, it's running, nothing's happening, but if I hit the left arrow, Scratch moves to the left. Okay. One of the things that you'll notice is that he can't go farther off the screen than the sprite is actually allowed. So the sprite's anchor point is kind of where he'll stop. I'm just going to stop my program and drag him back. Point him back in the direction by double clicking on this block. And I'm going to put the go to block right here. So when we start our program, give him a nice round number, go to. So every time we start our program, Scratch is going to go to 0, -100. And if we press the left arrow, he's going to point to the left and then move 10 steps. So now we're going to redo this for the right-hand side. So if we press the right arrow, point him to the right, and then move him 10 steps. Now, obviously, we could just say move 10 steps since he's already pointing to the right, but because we've got these left arrows or these left arrow instructions, this little block, that obviously turns him to the left, so we want to make sure we turn him right. So at its very basic stages, we have a game where we can move a character to the left and the right. Okay. Does anybody have any questions on that so far? I'll just keep the group chat up in case anybody has Any questions on that? Okay. So now there are some problems with this approach, and if you kind of look at what's happening every time I press the key, press, 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 press. If I hold it down, he kind of still moves, but you'll notice it's kind of jerky, and it looks like he's doing it in stages just because of the fact that we're telling him to move a certain number of steps. And in this case, we're saying 10 steps at a time. So it's kind of jerky. It doesn't look very smooth. So we're going to want to fix that. And the easiest way to fix that is with some logic blocks. So today's session is about logic, variables, and operators. And we're going to use at least 2 of those during this first part. So I'm just going to disconnect these for just a second so that they don't actually do their intended function for right now. We're going to try a different way of making this interactive, of using those arrow keys to make Scratch the Cat move left and right. So one of the things that game designers and animators and a lot of programmers like to do when a program does something over and over and over again is to create loops. We talked a little bit about loops last week when we did the forever loop, and we mentioned the repeat loop a little bit. But for the purposes of animation and games, a loop is really important because it allows you to not only check for things on a regular basis, but to do things on a regular basis. So for animators and game designers, every single game typically has something called a game loop or a primary loop. And the primary loop typically in most games handles things like drawing a character on the screen. So every single second or even multiple times a second, as fast as the game can go, the game can redraw the character on the screen. So if we move, we animate, we do something, the game is constantly redrawing that character over and over and over and over again. And that's kind of what makes animation and video games seem very fluid and seamless, is that the game is checking how to do things multiple times a second and making it very fluid. And then within that loop, within that repeated block, we can tell the computer to check for certain things or to do certain things. And you know, every single time we can check to see if a key on the keyboard has been pressed, or if an enemy is attacking the character, or if the character got a certain power up, how long does that power up last? Should, you know, as the loop is going over and over and over, we can have like a timer that says, is the timer up? Should the player still have this power up, or should the character still have this power up? So that's the kind of loop that we're going to set up to start off. Oh, perfect. We got a YouTube feed going too. All right, I'm going to pop out the live chat just so I can see what everybody else is saying too. Okay. So our loop is going to start with Scratch the Cat. So right away, I'm going to put in a forever loop. And now we're going to pick the types of things that we want Scratch the Cat to do or to check for as he's moving. So our first step is to check whether or not the left arrow key is being pressed or the right arrow key is being pressed. Okay. And we've already got a when key pressed block that we've used, but notice that this is kind of, this one triggers once we press the key. It's not something that's always checking. It just happens when we press the key. And that's kind of why we get that delay, because it only happens when we press the left and right keys. So we kind of get a press, action occurs, press, action occurs. And that's where kind of that stuttering or that lack of smoothness comes in. So what I'm going to do is, rather than using these events to determine that, I'm going to go into our first logic block, which we briefly touched on last time, but we're going to kind of go a little bit more in depth with some of these today. So our first logic block is if something happens, these little diamond shapes or jewel shapes that you see all throughout these blocks, they look kind of recessed, and that's because you can add things into those blocks. So you can add what's called a condition. And a condition is basically just saying that when something happens, this is that something. Okay. Oh, did I lose everybody? Here we go. So when something happens, do this, and this is what that something is. Okay, so in our case, what I want to check for is when the arrow key is pressed. And there's a couple different things that we can check for. I'm going to first start with our basic, what are called operators. And operators are basically just combinations of different things. Is one thing equal to another thing? Is something less than or greater than? Is something less than or equal to something else? Is something less than something else, but also greater than some other thing? And so these blocks here, you'll notice they're kind of in that jewel shape. And that means that if they're in that jewel shape, we can stick them into these little blocks over here. So in the later stages of this game, we're going to do things like check whether or not a high score has beaten another high score. So I can say if the current score is greater than the high score, do this set of instructions. And that's really the most basic form of logic that we can use, is just checking, comparing two different things. So operators can do math, they can pick random numbers, they can compare things, they can compare multiple things. But then we also have a different set of logic blocks that we've talked about last session, which is whether or not something is touching. So what we're basically looking for is to distill a true or false on whatever we're checking. So is it true that we're touching another character? Is it true that the current score is greater than the high score? Is it true that we're touching a certain key on the keyboard or pressing a certain key on the keyboard? So in this case, I'm going to use this block here, this operation block, or it's called a sensing block, because we're checking to see if something is happening rather than if something, some comparison is true. So in this case, I'm going to check to see if the left arrow is pressed. And I'm going to drop that into my session. So when we kind of chain this into our project, what's going to happen is our Scratch project is going to check forever if we're pressing the left arrow key. And if we are, it needs to do something. And in this case, we determined that we want the character to move a certain number of steps. Okay. Now, we've used the move block kind of pretty exclusively for our entire project so far, and even our last session. We switched to the glide block for a little bit, but there's some important distinctions about these blocks that we need to kind of clarify. One, move, as we saw, moves the character in a direction that we've specified using this direction block. Okay. We can also move the character just left and right or up and down based on X and Y coordinates. So at its most basic, this change X by whatever block is essentially the same as the move block, except that we specify direction based on this number here. So in this case, if the left arrow is pressed, I want to change the X coordinate of Scratch the Cat by a certain amount. Okay. So if I connect this here and start my program, what I should see is that if I press the left arrow key, Scratch the Cat kind of moves to the left. And even if I hold it down, nice and smooth. Again, if the YouTube or Hangout video isn't that quick or isn't refreshing quickly enough, then we may need to follow along to see exactly how smooth it is. But it basically moves him for as long as I'm holding the arrow keys. Okay. And so we're going to repeat the same block. But in this case, we're going to switch it to the right arrow and change it by +10. So now we've got two different conditions. If the left arrow key is pressed, do this. Otherwise, if the right arrow key is pressed, do this. So now, I can move him left and right. Okay, so now we've got a basic motion or movement going on just by virtue of a small loop in our program. And you'll notice it's highlighted in yellow, and that's just because it's constantly running. We put it in a forever block, so this loop is going to constantly check over and over and over again, whether we're pressing the left key or the right key, and then moving our character appropriately. Now, there's a small issue with this code block, and that is that technically our forever block is checking whether or not the left arrow key is pressed and whether or not the right arrow key is pressed. And if you remember last week, we kind of had an issue where when we ran our program, it did all of the instructions at the same time, and we didn't see any motion at all happen. And in this case, we could potentially run into that same situation. Somebody could technically press the left and right arrow keys at the same time, which I don't know if you can hear, but that's actually what I'm doing, is I'm pressing the left and right arrow keys at the exact same time. Okay, and that technically doesn't really break our game in any way, but you shouldn't be able to press both keys at the same time. So here's where we introduce our next block. The next block is called the if-then-else block. And the if-then-else block is very, very similar to the if-then block, with the exception that it doesn't do, or it does do the conditions immediately, but you can kind of step through a bunch of different conditions so that it's only checking one at a time. Okay, so in this case, we don't ever want the situation where the left arrow and the right arrow are pressed at the exact same time. So what we can do is first check if the left arrow key is pressed, and if it is, then we can change X by -10, just like we were. And all I did was I pulled that condition block and the actual instruction blocks from the one that we already had. So you'll notice it looks pretty similar, but now we have this else thing. So what this does is it basically says, if this is happening, if the left arrow key is pressed, do this. Otherwise, or else, do this. Okay? So we can say, if the left arrow key is being pressed, do this. If it's not being pressed, do something else. Okay? In this case, we don't really want it to do anything else if the left arrow key isn't being pressed, because otherwise what that would do is when the game starts, the left arrow key is not being pressed, so those instructions are going to fire right away. But we can move our if-else block that we had into the else block, which is then checking another condition. So if the left key is pressed, change our X coordinates by -10. Otherwise, if it's not being pressed, check for something else. In this case, is the right arrow key being pressed? If it is, then change the X coordinate by 10. If it's not, then don't do anything, because we don't have another else condition. So far, I'm going to get rid of this if-then block that's now empty. So far, what we're doing is we're saying, if the arrow key is pressed, do this. If it's not, check if the right arrow key is being pressed. If it is, do this. If it's not, just start the loop again. Okay. So I'm going to hit the green arrow. It's going to reset our project. And now I can move Scratch left and right. But I can't press both keys at the same time. If I try to press both keys at the same time, which again is not really possible in this game because you can't move both left and right at the same time, it defaults to the first step in our check, which is to move left. So right now you can only press one key at a time. If you try to press both, then it defaults to going to the left. The left key has precedence because it's the first one in our list. Okay. That's our first bit of logic. First bit of logic is just the controls for our character. He can move left and right depending on what arrow keys we pressed, and we're just saying if something happens, do something else. Now, we have a couple other blocks that we can use. We're not going to use these right now, but wait until is just like that wait block that we saw up here to wait for a certain number of seconds. But in this case, we're waiting until something happens. So we're waiting until a key is pressed, the mouse is clicked, a character touches another character, a score is greater than or equal to something. We're just holding the program until something happens. Next one is repeat until something happens. So just like it sounds, this just repeats over and over and over until some kind of condition is met. And that condition, again, can be arrow key, or mouse button, equal, less than, greater to, whatever we want, but it's going to keep on doing something. And as we get into some more advanced programming logic, we might want to use this more and more. But for now, this suffices. We've got the basics of our program. All right. Okay, so now our next step is to introduce what is actually going to happen when Scratch the Cat catches something. So we're going to put in kind of a temporary item here. So I'm going to start a new sprite from the library. And I'm just going to pick something that Scratch the Cat needs to catch in order to trigger something. So let's look for, I'm going to go with, I remember somebody mentioning this last time, a donut. So in our game today, Scratch the Cat is going to catch donuts. Okay. So what's going to happen is Scratch is going to move left and right, and donuts are going to fall from space. And if he catches a donut that falls from space, we're going to set a score. And the score is going to go up 1 for every donut he catches until we get a high score. Okay. So first, let's start with our donut. And our donut is going to drop from the top of the screen and come down as soon as our game starts. So when we click the flag, our donut is going to move down 10 items at a time. Okay. And again, we want that loop to happen. We want this to go on forever and ever and ever and ever. And so if I start my program, donut falls to the bottom of the screen. Move it back up to the top. Start our program, donut falls to the bottom of the screen. Okay. So our first step is going to be to set where this donut starts off from. So I'm kind of just dragging it into place and then moving our little go-to block just like I did with Scratch. But our game's not going to be very fun if the donut just falls from the same spot every single time we start our game. If I click the flag and the donut falls from the middle every single time, that's not going to be very fun. Okay. On top of that, our donut is really, really, really big, which doesn't really bode well for Scratch because he might just get crushed by some of these giant donuts. So the first thing that we need to do is change the size of the donut, and then we're going to change where it actually starts by letting our program choose exactly where the donut starts when the game starts. So you actually will have to move in order to start the game. So our first step is to go into the looks panel, and the looks panel, just like it sounds, is just a bunch of blocks for changing how our blocks look, what they do, as far as they can say something, so they can say hello, we can show them, we can hide them so that they show up on the screen or don't show up on the screen, and we'll use some of these blocks later on. We can switch the costume or the look of the donut. So in this case, our donut only has one costume, but we can load them up so we can turn it into an apple if he catches it, or we can turn it into something else. But in this case, we just want to change the size. So I'm going to set the size right when we start the game to something like 25% and see what that looks like. That looks a little bit more reasonable. It might be a little too small. So I'm going to try setting this to 35% and see what that looks like. Give me 50% as our winner. 50%. There we go. So the donut falls, it resizes itself to about 50%, and then falls from the top of the screen all the way to the bottom. Okay. Now we're going to set our game to choose where this starts. So as we mentioned last time, and you can tell again if I drag stuff around, our canvas down here at the bottom shows that the stage is 180 positive on the Y to the top, negative 180 on the bottom, and then the X is negative 240 and positive 240. So we can move these characters or these items all the way from negative 240 to 240, or from positive 180 to negative 180. So our first step is going to be to set our Y-axis to as high as it can go, which is 180. So we'll start up at the top of the screen, as high as it can go. And then we want to randomly choose where it starts between negative 240 and 240. Okay, and that's where our operators come in. So we've already done some logic. Now we're going to touch on the operators. Operators allow us, like we mentioned, to do some math, to compare things, to compare multiple things, or compare if one of a multiple set of things is true. But in this case, one of the things that it lets us do is choose random numbers. So what we're going to do is we're going to choose a random number between 240 negative and 240 positive, which is our X and Y coordinates. And we're going to tell our scratch block when we click the flag and our game starts, set the size to 50%, have our donut go to a random spot between negative 240 and 240 up at the top of the screen, and then change by a negative. So every time we hit the flag now, our donut should potentially jump to a different spot on the screen, which it is. Every time I click the flag, it jumps to a different part on the screen from left to right, and then starts to drop. Okay. So our first operator that we've used is the random number operator. And we can use this for anything. If you want characters to start off with a certain amount of health or hit points, so that you know, they have a certain amount of ammo, or a certain amount of health, or a certain amount of you know, points that are applied to them, you can use those random numbers to set those kinds of things. In this case, we're just setting a random start position for our donut. Okay, now we have to make our first programming decision as far as the structure of our program. So we've got a donut falling from the sky. I'm going to change its speed just to 1, to make it a little bit easier to catch initially. But later on in our program, we're actually going to make the speed increase as the program goes on. Okay, so in this case, we'll leave it as -1 to kind of give it a nice slow fall, so that our game starts off kind of easy. And again, we can move Scratch the Cat around, so he'll be able to do it. But now we need to decide what happens when we actually catch or touch the donut. Okay? And so our first bit of kind of project management in terms of the program is, where do we want that logic to happen? Do we want the donut to check if Scratch the Cat is touching it, or do we want Scratch the Cat to check if he's touching the donut, and then update our score from there? Okay, so in this case, we could start off with Scratch the Cat and say, you know, in our little loop here, we can also check if he's touching a donut, then do something. Okay. But one of the things that you'll notice as we get later on into the program, or as you start to play the actual game, one of the things that you'll notice is that obviously a game isn't fun with just one donut. Okay. So if the donut touches scratch and we tell it to disappear or do something, then kind of the game is over. So we're obviously going to have multiple donuts that need to check all at the same time whether or not Scratch the Cat is touching them. So although we could put our block here in Scratch the Cat's logic to check if donuts are touching him, it makes a little bit more sense to have each donut checking if Scratch is touching it. So in our forever block, I'm going to add a control block that says if we're touching Scratch the Cat, okay, do something. So for right now, we'll just hide it. If Scratch the Cat catches the donut, then hide it. Okay. So when we start our game, if he catches the donut, it hides. Okay. Now though, if we start our program again, I don't see my donut. Okay. And that's because this is the same donut that we left off with the last time we ran the program. So we need to make sure that we show the donut when the program starts. Okay. Start the program. When we click the flag, it shows the donut, sets its size, puts it in a random spot, and then does our game loop. Change course by -1, and if we touch Scratch the Cat, hide. Make sense so far? Okay. So now our next step is to set up a score for the game. And again, our game is very, very basic right now because we only have one donut and one character. So our high score is max 1 for right now. We'll fix that as we go on a little bit later. But for right now, our score is just going to be able to be set to 1. But we need to keep track of a score. And so the way that we can do that is with our last topic for today's session. And we'll go back to some of the logic and the operators, but our last topic is variables. And variables are basically what most programming classes or most programmers will refer to them as are buckets that we can store information in. So something like a high score. A high score changes normally. And so if we wanted to run our game, we could kind of just keep track of what the score is and put a number up on the screen. If it's 1, go for it. If we catch another donut, change that to 2. If we catch another donut, change that to 3. And so on and so forth. But in programming, it makes sense a lot of the time where you may not know what the current high score is, or you may not know what a certain amount is. And so you just want to check whatever that current value or what the current amount of that is. And that's where variables come in handy, is we can tell the program, if I'm counting from 1 to 10, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and say, when we get to 5, do this. If the current number is 5, do this. But it's easier to keep track of a variable called count and say, if the current count, or if count is equal to 5, do this. So when I count 1, 2, 3, 4, 5, if it's equal to 5, do this. Okay, and those are variables. So in Scratch, under the data blocks, I can make a variable and I can call it high score. Now you can actually name this whatever you want. Most programmers use something called camel case, which first letter starts off as lowercase, and then every other letter of every word is capitalized. And the reason for that is just so that you can pick out variables when you're looking at code. In this case, Scratch kind of keeps track of them for us. So I'm just going to write high score. Again, you don't have to capitalize it the same way. And then we have an option. Do we want every single sprite or every single object in our game to have access to this? Or do we only want the donut to have access to this? Okay. And in this case, I'm going to choose for all sprites because we may have other things that affect your score. Actually, maybe I don't even want this to be high score. I'll name it current score because we may want to add a high score later on to check for that later. So current score, and I want every sprite to check it because later on we may want to introduce items that drop your score. Maybe there's, you know, a donut, and then there's an apple. And in our game, Scratch the cat who lives on the moon loves donuts, but he hates healthy food. So donuts will give you a point, and healthy food maybe will remove 3 points. So I want that to be accessible to all sprites. So what happens is when I add that sprite in, you'll notice that the current score pops up here. You get a little box in the corner that says current score. And then we get a set of blocks just for current score. So set current score to 0, change current score by 1, show variable current score, hide variable. And again, if you double click these, you can kind of see what they do, which is just showing or hiding our score block here, changing the score by 1 at a time, and then setting the score to 0. So obviously when our game starts, we want to set the score to 0. And then when Scratch the cat touches a donut, we want to change the current score by 1. Okay, so again, if we just go through this, when we press the green flag, our current score gets set to 0. We show our donut, and that's because I'm on the actual donut sprite. We set the donut to 50%. We tell it to go to a random spot from left to right, all the way up at the top of the screen, so negative 240 to 240, but at Y 180. And then we start our loop. Change the Y position by -1 to make it fall down. And if it touches Scratch the cat, change the score by 1. If it touches it, our score went up by 1, and then it hid. Okay, and just to kind of show that our logic is working, I'm going to make it so that Scratch doesn't catch it this time. You'll see that our score doesn't change. The donut goes all the way to the bottom of the screen, and then it just kind of sits there. Now we have no way of touching the donut because it's past where we can reach. Okay. So now we have some things that we want to check. We've obviously got our score set up here. This isn't perfect because right now our score is kind of tied to the donut. And again, when we get multiple donuts, we don't want to have multiple scores. So we may end up moving that a little bit later. But for right now, we have a working game, a very basic working game. It's not a very fun game. It doesn't last very long, but it works. Our score gets set to 0 when the game starts. Everything resets to its position. And then the game moves. So now what we're going to do is we're going to kind of just do some cleanup, some management of our program. I mentioned earlier that we may want to have a high score at some point in our game that we keep track of. And with Scratch, variables, as long as you're in the same session, and what I mean by that is as long as you haven't closed out of Scratch completely, as long as you're in here, you can start your program as many times as you want. And all of our variables will stay the same unless we set them using one of these blocks to change their value. So what I mean by that is I'm going to make a variable called high score, like we talked about at the beginning. And again, I'm going to set it for all sprites because later on we may have some items that don't give you points, but they take away points, and we want them to have access to those too. So now we have a current score and a high score. Okay, and our high score, is one of those things that the entire program might want to keep track of. So right now, all of our blocks that we've used so far only work on each of the sprites. So Scratch the Cat does his code blocks, and actually we can get rid of these. So there's our first bit of cleanup, is to get rid of the stuff that we're not using. Since we've got it in our loop now, we don't need those left and right arrow blocks. And now we need to think about where we can kind of simplify our program and where we can clean it up a little bit. Where can we make it make more sense? So that when somebody else comes in and looks at our project, where does it make the most sense for everything to stay? So our high score and current score, those are two things that I think personally, and again, there's more than one way to do anything in programming, but I think personally that the best place to put it, even though this is kind of the easiest place to put it because of the fact that it's right in line with what's actually making the change. So when I say that, the donut is what's actually implementing the current score. When Scratch touches the donut, the score goes here. But we don't really need the donut to set the score. Again, as we get multiple donuts going in here and they're falling from the sky, we don't necessarily want every single one of them to reset our score every single time it shows up on the screen. Okay. Scratch the Cat also isn't the best place to put it, because even though we only start him once, we might have other stuff that he's doing that affects the high score. As I mentioned before, we might have bad or good food that he doesn't like that affects the score. So one of the things that we can do is we can add scripts to our stage, just like we did to our sprites. We can add stuff to our stage. Okay. And the way that we do that is the same way that we do it with the other ones. So I'm going to say when we click the green flag, take that high score. I'll disconnect this first so I don't lose it. But I'll take that high score and delete that block from here. And I'm going to re-add that block on the stage. So I want to set the high score to, or sorry, not the high score, the current score to 0. So I'm going to grab this set blank to 0, but I want to choose current score from the little drop down that shows up. So the current score resets at the beginning of every game. Okay, the high score doesn't, because the high score should be the high score no matter what, as long as we're playing in the same session. And for all of our sprites, that will still work. We can still change the current score here by 1 because we told that variable to be available to all sprites. Okay. And now we can add in a loop, just like we did for Scratch the Cat and for our donut, that checks every single frame. And what we're going to do this time is say, if the high score, or sorry, if the current score is greater than the high score, I'm going to do that again. I'm going to delete this block just so you can see what I did. So I went to my operators tab and I looked for the block that compares. Is one thing bigger than the other? Is the high score greater than the current score, or is the current score greater than the high score? And again, there's more than one way to do this. So we could check if the high score is lower than the current score, or we can check to see if the current score is greater than the high score. And that's the one that I'm going to choose because to me, in my head, it kind of makes sense as to that's what we're actually checking. We want to see, is the current score, did we beat the high score? Is our current score higher than the high score? So all I do is I go to my variables and I just grab my variables and drag them into this little block. Is the current score higher or greater than the high score? If it is, okay, then I want the high score to change. So again, set the high score to some number. Okay? And I can change the number, as I mentioned before when we were counting. I can manually go in, and every single time the high score is greater than the current score, I can set that high score to go up by 1. But the easier way to do that is just to set the high score to whatever the current score is. Because obviously now, if our current score is greater than the high score, then it must be the new high score. Okay? So if the current score is higher than the high score, set the high score to whatever that current number is. Does that make sense to everybody? If you want, you can just type a message into either the live chat, or if you're in the Hangout, go ahead and type it into the chat box. But just give me a thumbs up or a yes to let me know that I understand that. If you need additional clarification or anything, just write that in there, and I can kind of go over that. But so right now, our program, our game functions in its most basic. We have a high score. So what should happen is our current score is 0, our high score is 0. If we catch that, then it should set our current score to 1, and because our current score is then higher than our high score should also set itself to 1. So let's just make sure that works. Okay, and if you look at our window here, that's exactly what happened. Our current score got set to 1, and our high score got set to 1. Okay, our game is still running, but unfortunately we have no more donuts to go in. But our logic at least works. Our donuts drop, Scratch is able to move around, and our high score is set. So as you can see, if we look through our scripts, we've got our basic logic, which is just anytime we're using really these control blocks. If something happens, do this. If something else happens, do something else. If this happens, do this thing. If this happens, do this other thing. And every single one of our sprites and our actual stage itself has logic. Okay. We've used variables to keep track of our current score. So we've set a variable for the current score. And then we've used operators to check if our current score is higher than another score. And then we also used operators to pick a random number. So just kind of take this back to where we were last week. Every single one of these items is just like a recipe. It's a recipe that the computer is doing in the order that we tell it to, but it's being done immediately. So all of these loops here are happening immediately. They go on over and over and over again, 100 times a second, or however fast your computer is. It's happening multiple times a second in order to do what we want it to do. Now, there's one final piece that we might want to put in here before we go in and set up all of our multiple donuts falling from the sky, and that's what we're going to do next week when we talk about clones and cloning characters. But you'll notice that when our game goes, if we don't catch it, the donut just kind of sits there at the bottom of the screen. So one of the things that we might want to do is just make that donut disappear if we don't catch it. If we don't catch the donut, then we want it to disappear once it gets past the point where Scratch can't touch it anymore. Otherwise, what's going to happen is we're going to lose, or we're going to have donuts, lining the bottom of the screen when we put our multiple donuts in there. So let's figure out a way to make the donuts disappear once they get past Scratch. Okay. Again, you'll notice our current high score is 0 because we started the game, but our high score has stayed at 1 because we didn't have any logic to reset it. And just, with a high score, you don't really want to reset it. So that makes sense. But we're going to want to go into our donut, and we're going to want to add another bit of logic. So what I like to do whenever I'm coming up with the logic for my programs is I want to kind of say it in English first, like just kind of wrap it around in my head and say, if the donut does something, then do something else. Okay, and that's the logic that I'm kind of going for. But I need to decide exactly what I want to check for. And in this case, I need to check to see if the donut is below Scratch the Cat. Okay, and there's not really a block anywhere that says if the donut is below scratch the cat, then do something. So we need to kind of figure out what our logic for that is. So my first step is just to figure out how low can the donut go? How low can it go before we should consider it a missed donut? So I think right around here, negative 175 looks like that's pretty much where scratch can't get to it anymore. Okay. So what I want to do is I'm going to check to see if the donut's Y position, like where it is from top to bottom, is lower than where scratch the cat is, which we already determined was about negative 175. If I look at my my donut information here by clicking on the little letter I can see that the current position is negative 161. So we might actually want to make that negative 165 because that's where its current position is. So if something, the current position of the donut is less than negative 165, do something. Okay, so let's get our if block. And we want it to check. So again, all these blocks will happen simultaneously if we don't have it set to wait for something. So it's going to check if it's touching scratch the cat. And it's also going to be constantly checking if this is true. So if whatever the position of that donut, and we actually have a variable that's already set up for us. Scratch, the app, automatically has variables for a sprite's X position, Y position, and direction so that we can check against those things. So I'm going to use this variable. We didn't have to set it up. It's already here. We didn't do anything to create it. It's there by default. In fact, if we look at Scratch the Cat, he also has those variables set up. So every sprite will have these three variables automatically. It's not something that we have to figure out. And I'm just going to drag the Y position. So if the donut's Y position is less than negative 165, then hide it. Okay. So again, we start, we show it, set its size, pick a random spot, have it start dropping, and then once it gets past where scratch can reach it, it disappears. I'm going to try that. I'm just going to make sure that scratch the cat can't get to it. You just want to make sure that if somebody misses it very, very closely. Okay, so you saw I kind of moved over where the donut was. I couldn't get it anymore. And so then it drops. So Bob asked, I trust that sensing and operators are the only two types of scripts that can be plugged into the condition socket into logic blocks. Anything can be plugged into the logic blocks as long as it's in that jewel shape. So I'm pretty sure that the only ones that are on here are sensing blocks and operators, but you can combine them. So technically you could have variables that go in there that kind of are mixed and matched with those. But yeah, it looks like the only ones that are operators, which again, you can plug variables into, and then the sensing blocks. Yeah, so if the shape doesn't match, essentially, that's how you can tell that you can't put that in there. Does that make sense, Bob? Cool. Okay, so we're almost out of time, so I just want to briefly kind of recap what we went over. We did our logic using the if blocks under control, and then if then else blocks to determine our left and right controls on the keyboard, and then our logic to check if it was being touched and what the high score was, and all that. We used operators to check our conditions, whether something was greater than or less than something else, and to also choose a random number for the position of our donut. And then we used variables to keep track of our current score and our high score, which will make a little bit more sense next time. But we have those set up. So if you decide to make a different game, you might want to use different variables for different things. We've made, for my group, Spark App League, we've made paint programs in the past where our variable was whatever the current color was that we wanted to paint with. And so you can save any kind of data or any kind of information to variables. You can save names, numbers. So they can come in handy for all kinds of different things. We're primarily going to use them for numbers in our game. But next week, what we're going to talk about is some of the more advanced features. So again, you have a little bit of homework if you want to continue through with this. I'm just like I did today, I'm not really going to check your homework, but it's something that I think is really important for people to play around with. And that is cloning. So cloning, what cloning basically does is it allows us to take sprites that we've already created and make duplicates, just like it sounds. You can clone a sprite as many times as you want. And those clone blocks are under the control section. So we have the option when something is cloned to create a clone of something and also to delete clones. So play around with those between now and next week and see if you can figure out how to get our donut to happen multiple times so that there are multiple donuts dropping from the screen. And then if you want to take it a step further, see if you can figure out how to also take the donut that we made and modify that, make a different sprite like the apple that instead of adding to our high score, removes from our high score, okay? You may want to set some logic that says that our high score can't go below 0. So if it's already 0 or lower, then just keep it at 0. And that's some additional logic that you might want to do. You may want to add bonuses that multiply our high score. So if you catch a special type of banana, or sorry, not banana, a donut. If you catch a special type of donut, maybe that special donut gives you 3 points instead of just 1 point. So that'll be your homework. We'll talk about a lot of that stuff next week as we get into the cloning and some other Scratch features. But for right now, go ahead and take that, play around with it, and see if you can figure out how to do that for next week. Okay? So Bob, if you have anything else that you want us to go over or to recap, or if anybody else has any questions, I'm going to stick around for just another couple minutes unless nobody has anything that they want to give. I'm checking the live chat. It doesn't look like anybody watching on YouTube has asked anything in the live chat. So if you do have questions, feel free to ask away. And if you need anything else, you guys know where to find me. Okay, sounds good. Thanks, Miguel. Have a good day. We'll see you next week. Cindy, did you have any questions? Okay, looks like Cindy's good. She left. Okay, sounds good. Then I will see everybody next week. And good luck with your homework. We'll see what you guys came up with next time. Thank you, everyone.